Ave, welcome, well met. My name is Michael, son of Michael, son of Michael. You can call me Josh. I am delighted to be here today. I am sort of a prodigal child of the Morrison Planetarium. I used to work here a long time ago, and it is a delight to be invited back to give a show like this. So, thank you for joining me here. You folks are welcome to cross. We are doing a very special kind of presentation, something that the Morrison does not always do, because the Morrison prides itself on doing accurate, precise, informative, factual information, and I'm going to be lying through my teeth for the entire show. So, this is a little different. We want you to come in with that primer. The people who exit late, they're going to be really confused. But for the show today, we're going to be talking about medieval astronomy. When they pitched this show, my little heart just leapt out of my chest. Not only am I a planetarium, I am a dedicated medievalist, part of the SCA. It is a joy to be here today and to be telling you all about this very silly topic. So, with that, in the Morrison Planetarium, they have a wonderful planetarium. It is capable of doing all sorts of amazing things. And tonight, I wanted to show you, we have made a painstakingly accurate, precise recreation of Bay Area skies. Beautiful. Look at those stars. You might even see a couple. So because we are looking at a modern sky, we don't get to see that much. But tonight, we want to cast our minds back, not just in terms of having a darker, more luxuriant, decadent night sky full of stars. We want to cast our minds back in time. So we are going to be thinking of the sky under a medieval conceit, a conception of the universe where Earth is at the very center, and we see the heavens moving above us. So take your mind, transplant it back in time, but as you're doing that, do me a big favor and remind yourself that Morrison is a wonderful and immersive theater, but it is tilted. You will notice as you're especially climbing those stairs, I apologize, they're very steep stairs. We're imagining ourselves laying back in a field and looking up. So the entire night sky will be tilted. I want you to tilt yourself a little bit too, so that it matches up nicely. For the presentation, we are going to do everything we can to make it a nice, dark theater so that everyone gets to see these beautiful stars, but we need your help. If you brought a cell phone, flashlight, flash cameras, blinky shoes, they're not period, but they are cool, do us a big favor and make sure they stay as dark as possible for the duration of the show. If you manage to smuggle in any food or drink, please do us a giant favor and smuggle it right back out. We do encourage you to remain seated for the duration of the show. It will get dark in here. That is intentional. We don't want people moving up and down these daunting stairs in the middle of the show. Not only is it kind of dangerous, but you also walk in front of the projectors and make a giant human-shaped hole in the universe. This was never scientifically accurate, so please refrain. Okay, with that, I've reached the top of the stairs. I'm going to jump back into the pilot's booth, sit back, relax, and we'll begin shortly. It locked me out of the own booth. Okay. With that, we are looking out at our own night sky. We are going to cast our minds back, like I said, a couple hundred years into the past, and as we do, we are going to enjoy the night sky as it should be. Take a moment. Really look. There are so many more stars than we get to experience on a daily basis. If you've ever been to a truly dark night sky and seen something like this, say yo. I'm jealous. We never, ever, ever get out enough to get to experience it. So if you, as a medieval personage, walked out, lay in your field, and looked up, over the course of a night, you might notice some motion. That motion's subtle, but it's omnipresent. You are always seeing it. We are seeing stars gently move. If you paid enough attention over the course of a very long time, you would notice that they move in a specific pattern. They are rising in the east, over here, and setting in the west, over here. As the stars are moving at this much accelerated rate, they tend to move together. And what do I mean by that? Well, let's find an asterism, a picture in the star many are familiar with. Right up here, we have the behind us of Ursa Major. This is the Big Dipper. Now, the Big Dipper, many can pick it out, sometimes known as the Starry Plough. This is a great constellation to keep track of. If you imagine water spilling out the bottom of the Dipper, it'll fall onto Leo the Lion. Now, as we're watching Leo's head over here, you would see those stars move together over the course of an evening. They're not going to drift apart. They're not going to change position. They are all fastened to a giant material sphere that we call the celestial firmament. Now, this is known because the stars never change. They always stay in their position. They all move together. So we here on Earth, the terrestrial firmament, look up at the celestial. On Earth, our world is made of fire, water, earth, and air, the elements. When we look up to the sky, we see a fifth element. A great movie, not what we're talking about. But we are looking at a quintessence, a fifth substance, the celestial fire. That is what powers these beautiful shining objects. That is what we are seeing up here in the celestial firmament. Now, in order to observe all the motions we see in the night sky, we are going to change things a little bit. We are going to look north. And as we do, the entire planetarium is going to shift. So if you are, shall we say, prone to motion sensitivity, now is a great time to close your eyes. Here we go. We're shifting. Don't puke. If you are motion sensitive and you have your eyes closed, it is safe to open them now. Okay, so how do we know we're looking north? Well, once again, we can find our Big Dipper. We can trace those two stars right here to our North Star. Keep your eyes on that point as I begin time's motion once again. Things are moving the opposite direction, but remember, we're looking the opposite direction. So things are rising in the east, moving across the sky, and setting in the west, except for the stars around the North Pole. We can see our sun coming up, but again, through the magic of a planetarium, we can make our atmosphere clear. You'll now notice these stars are moving around that single point. Now, this is because the celestial firmament is rotating around Earth. Earth could be rotating, I guess, some philosophers suggest. The celestial firmament could be rotating as well. This creates an interesting conundrum. If we imagine that the celestial firmament is rotating, then something larger than the terrestrial firmament is moving. And if the terrestrial firmament is too large to move, that creates quite a puzzle. So astrologers, in the modern sense, have decided this is a problem for philosophers and no longer concern themselves with it. So as we are looking up at our night sky, we can see these constellations moving together. They are moving around the spherical Earth. Now, I do want to assure you, we are enlightened medieval people. We do not know the Earth is flat. We know the Earth is a sphere. We're not weirdos. There are people out there who imagine the Earth like this. We don't like them. When we look at our spherical, coin-shaped Earth, there are some people who might say, okay, well, since I put a round thing down and it didn't go away, the Earth must be flat. They are unenlightened. How do we know that this is not the case? Well, all you have to do is watch a lunar eclipse. If you were to watch a lunar eclipse, looking up into the sky, we're going to make our moon significantly larger so we have a chance to see it. I still can't see it. Something weird is happening. Hold on one second. Oh, okay, there's the moon. We are going to fast forward time, and as we do, you'll see the moon change the amount of illumination, but the shadow that's falling on it is not a line, you'll notice. It's round. Now, if there was a lunar eclipse that happened exactly at midnight beneath a coin-shaped Earth, yes, the shadow would be round, provided we're not a square coin. But at any other time, any other lunar eclipse, there would be a line or an oblate shape, and we simply do not see that. So by this proof and many others, we know that Earth is a sphere. In fact, the ancient Greeks went so far as to calculate the size of that sphere. So to say that Earth is a coin is to simply ignore the knowledge of the ancients and today. It's a ridiculous idea. So we will speak no more of it. Anyway, since Earth is the center of the universe, we are going to build out our understanding of Earth as such. So today in astronomy, our sophisticated astrologers and astronomers are working on understanding the night sky as well as they possibly can. In order to do this, they have created a numerical system to help understand exactly what we are seeing. To do this, you might notice letters appearing on the edge of the dome. That's to help us see where the meridian goes. We're coming in at a weird angle, though. Let me try this one more time. Oh boy. Okay, we're going to go and look directly south. Thank you, Jacqueline. As we rotate to look exactly south, I must have interrupted it too soon. As you are laying flat on your back, you might imagine that this is straight up at 90 degrees, and we are seeing angular demarcations going down from that. This is the meridian we see connecting north and south. So as we see stars rising, they rise before the meridian. When they set after the meridian. So when our sun is before the meridian, we say that it is antemeridian, AM. When it's post-meridian, we say that it's post-meridian, PM. As the sun moves across the sky, we can chart its position. Likewise, we can chart the position of the stars. So if we wanted to know exactly how high a star got as it crossed the meridian, its greatest separation from the horizon, we have created far out, futuristic instruments like this. Ooh, ah. This is the quadrant muralis. Now, this is a wall quadrant. You can see here very small angular measures positioned around the side. The medieval equivalent of grad students cruelly forced to type down exactly what the lead astronomer points out, and a tiny window right here through which the stars might be seen. They can then figure out, based on a mirror that slides back and forth, exactly what elevation that star is at. This is a sophisticated astronomical instrument, the height of technology for its time. You can see on the outside of Tycho Brahe, right here is Uraniborg, a bunch of other astronomical instruments, including an armillary sphere right here, super cool. But I want to indicate that is not a telescope. A telescope is unknown at this time. It is a simple tube for identifying exactly where an object is in the sky. There are no lenses within it. So Tycho Brahe is leading the charge when it comes to accurate positional information for exactly where stars might be seen. This is important. Why is it important? Well, turns out there are some ambiguities in astronomy. Cast your eyes over here to a constellation we know as Orion. Now, when we think of Orion, you might connect the dots something like this to show yourself Orion. Here's a question, though. What is his right arm? What is his left arm? What's his leg? You might draw this in a specific way, but there's no guarantee that the person next to you is connecting these stars in the same exact positions. Now, when I observe Orion as a sophisticated astronomer, I see something like this. And I wish to tell my counterpart in Germany, please observe and indicate exactly the color of a star located by Orion's left elbow. I, of course, mean this star. But those savage Germans, they draw Orion like this. That's not even the right number of stars. So if I say the star closest to Orion's left elbow, they might think this is the star I'm talking about, and goodness knows which actual star in the sky they'll find. So with that, all of a sudden, we have a great degree of ambiguity introduced. But with instruments like the quadrant muralis, we can begin to give a mathematical position to these objects in the sky. And to better understand them, this is a gigantic leap forward in astronomy and really indicates the end of observational astronomy. We're about to thoroughly understand the position of the night sky, and further research will be meaningless. Now, beyond that, there is a fly in the ointment, a challenge, something that does not behave correctly. And I'm, of course, talking about our wandering stars. The planetes, the planets. Perhaps best known amongst our planets are the sun and moon, planets of the highest order, the brightest objects in the sky. The sun, of course, you can see here gliding about on his solar chariot, the scepter of authority, the source of all light and good, the thing that creates the health of the earth, a symbol of sovereignty, power over the rest of dominion. This is, of course, associated with the masculine. The moon, associated with the feminine, has a bunch of bad stuff associated with it. Can't think of why. But you may see a pitcher of water held in her hand. The tides are associated with the moon, as is the constellation Taurus, and she carries a brand as well, indicating the light she carries through the sky. We also have our minor planets, things like Mercury. You can see here with a skin of wine, indicating party hardy. The caduceus of Mercury. This is a symbol of commerce, wealth, prosperity, and the good things that the earth has to offer, including friendship. We also have the planet Mars. Mars is a bringer of war, bad tidings. You can see Capricorn next to it. Down here, you can see a banner, a sword, and again, that flaming brand. So the red color of Mars is a great insinuator, an easy way to identify it. Mars is a planet of ill omen, as is Saturn. Saturn, disease, aging, pestilence. This can be a challenging planet, one you do not want wandering through your birth constellation, but thankfully it moves very slowly in its old age. And lastly, the king of the planets outside the sun, Jupiter. You can see Jupiter here with a hound and definitely a crab right there. Also carrying the arrows that symbolize the lightning bolts. This is the brightest of the planets overall, except for the planet that is missing from this codex, Venus. Venus is situationally as bright, if not brighter than Jupiter, but Venus, the symbol of love, beauty, was not recorded in this beautiful set of illustrations, so I don't have a cool picture to show you. But as we look at the wandering stars, as they change their position throughout the sky, we do see something interesting, something curious. Mostly, over the course of a night, they move rising and setting with the rest of the celestial firmament. But if you track their position over a long enough period, they would do something unusual. With the sun and the moon, they'd slowly move counter the rest of the sky, but then they would change direction and then resume their march. This brief period is a backwards walk, a retrograde, if you will. Now, when Mercury went into retrograde, you might not want to strike a new deal. You might not want to start a new friendship. This could indicate to you exactly what you need to be doing at that time of year. Likewise, we can count the retrograde orbits of Venus, Mars, Jupiter, and Saturn. As we track these objects in their march across the sky, it is important to pay attention to these changes to really understand exactly what's going on. Now, these planets all move on their own celestial sphere. Centered around the Earth, they rotate and give meaning, quality, and this ephemeral changes that make life constantly different. Were they to stay in a single position, life would be unchanging, inflexible, and constant. Who wants that? We want the dynamic, interesting parts of life, but this shows us the perfection of the night sky. This truly is the system that makes perfect sense if we were to imagine the visualization of all of these worlds moving around the firmament that is Earth. We might see something truly beautiful and elegant. According to the Ptolemaics, we might see something like this. This. Now, this beautiful manifestation is based on the ideas that we can see the Platonic solids separating the worlds from each other. This divine celestial mechanism shows us the qualities, the known characteristics of each of the planetary spheres. Truly exciting, truly wondrous, and perfection itself. Now, we have been observing with our sophisticated astronomical instruments, and I'm going to show you the data. We're going to show you exactly what we see from Earth. Are you ready to see this beautiful celestial dance? Check it out. That definitely looks just as elegant, right? Not like a bowl of Dayglow spaghetti. I don't know if spaghetti's been invented yet. But looking at this system, this is hard to explain. What's going on here? Well, it turns out that I perhaps have oversimplified exactly what we're seeing. Yes, the planets do move on these perfect crystalline spheres around the Earth, but I forgot to mention this one little kind of important detail. They don't actually travel just on the sphere. They're actually moving on something called a deferent. Now, what do I mean? Well, as Mercury travels around the Earth, it moves on this little circle as well, an epicycle. And there's this greater circle called the deferent, and there's this other point next to Earth called the equant. And well, they don't really go around the equant or Earth, they go around a point in between them. But I want to assure you, this is in fact quite simple and perfectly explains everything. If you can't get it, that's your problem. But as we see, this simple diagram perfectly explains the positions of all of these planets, and we thoroughly understand exactly what's going on. But there are still some errors, and we're working on correcting those, and we think all we have to do is add a few more epicycles, and we will have really nailed it. Well, it turns out the universe is far more interesting, far more complex than we have any right to consider. There is a notion gaining popularity along the Silk routes that tells us that Earth is not the center of the universe, that perhaps the sun is at the center. Heretical, I know. You make my heart sing with your boos and jeers. We know this can't be true, but let's examine this idea. If this were the case, the sun were at the center, how would we possibly explain what we see in the night sky? As the planets traveled around, if Earth were merely a planet and not the firmament, when we were on this side of the sun, all of these constellations would appear super big because we're close to them. Explain that, heliocentrists. As we went over to this side, they'd get all tiny in the sky, and these ones would appear super big, and simply we do not observe that. QED, this can't be true. We also don't feel a sensation of motion. If Earth were spinning around the sun, we'd feel the wind howling past us, like sticking your head out of a carriage, and simply that is not the case. So we know this is not true. But some of our leading astronomers, like one of my personal favorites, Tycho Brahe, have lent some support to this notion, albeit lukewarm. His idea was that, well, perhaps some planets might orbit the sun, but the rest surely orbit Earth, or at least a point between the sun and the Earth. This is the Tychonic universe. So you can see Luna, the moon, orbits the Earth. Mercury and Venus orbit the sun. Mars orbits the Earth, but then Jupiter and Saturn orbit a point in between them. Doesn't really make sense to me either. Now, this is a conception to be sure, but it can't be correct. No one broadly supports this. It's an interesting mathematical take, one supported by followers of another astronomer, Copernicus. Now, Copernicus, a cowardly man of sorts, wrote out an explanation of the sun at the center, but it was only published after his death. Now, he claimed in his life that this was merely a mathematical tool to make the calculations easier, but his omnibus presentation upon his death made clear that this was a model he supported on understanding of the sun as the center of the universe. Now, his model does not work. Let me make that abundantly clear. But taking the data tables compiled by Tycho Brahe, Johannes Kepler put forward that perhaps what we are actually seeing are ellipses, not spheres, not circles. With these ellipses, he claims the math works better. I don't think that's necessarily true, but he's better at math than I am, so I'm not going to try and shout him down. But unless there was some kind of far-out futuristic instrument that came about in the next few years to prove one of these models correct, it's all speculation anyway. Thank goodness there's no one named Galileo who's about to start using a telescope. But with this, I will end the silliest part of our presentation. We are talking about a model, a conception, an idea based on looking up at the skies and trying to understand exactly what's going on. And to me, perhaps the most exhilarating part is that these astronomers sat beneath the same sky we do. They looked up and saw the same stars, albeit without that hideous light pollution, but using their minds, their mathematical ability, and their own observations, they came to understand better our place in the universe. Now, to me, that is something truly special, truly wonderful, but they did not derive these principles whole cloth. Sure, these are great scientists, if we can assign that label to them. It is a very modern label. But they were people, and they were people who learned from other people. All around the globe, astronomers had been sharing these ideas, this information, allowing each other to build on their models, and to me, that is the very best part of science. So I would invite all of you to take a moment, if you have the chance, to go outside on a clear, dark night and look up. The darker the sky you can find, the better. But when you look up at these stars, remind yourself that we are connected to that same wonderful tradition. We are privy to the same knowledge. We could prove these same things. And if you are interested, I'm working on some experiments you can do yourself with your TI-83 calculator and a stick to prove that we are, in fact, living on a sphere and how far that sphere is from things like the sun and the moon. So if you are interested, swing by the booth. I would love to share more information with you. It's still a work in progress, but it is an exciting thing nonetheless. But with that being said, I would like to thank each and every one of you for joining me here tonight. On behalf of myself and Morrison Planetarium, thank you, and have a wonderful rest of your nightlife.